Hello everyone. In this video we're going to be talking about rotations. Our objectives are that by the end of this lesson you should know that rotations spin an object around our center of rotation. For us it's going to be the origin, and you should understand that rotations preserve the size of the preimage. It's not going to make anything bigger or smaller. You should be able to rotate a preimage by multiples of 90 degrees on a coordinate plane. That was a lot to say, but it just means we're going to be doing 90 degrees, 180 degrees, 270, or 360 degree rotations. To start off, make sure you're copying this down. Rotations on the coordinate plane. A rotation spins a figure around a fixed point called the center of rotation. In our examples, the center of rotation will be the origin. In geometry class, you'll be able to rotate these around anything, but in this class, we only want you to be able to rotate things around the origin, which is 0, 0. And we're going to rotate things in increments of 90 degrees. You need to pay attention to the direction of the rotation. There is a difference between turning this way. If we go this way, this is similar to, if we have a clock, it goes 12, 1, 2, 3, 4, 5, 6. This is called clockwise. The opposite direction from that is counterclockwise. The reason why we can't just say spin to the right or spin to the left is because, well, if something is starting right here and we want to turn it counterclockwise, then we would need to continue going that direction. But if we start at the top and we want it to go to the right, if we want to turn something to the right, then that would be in the other direction. So depending on where the starting point a preimage is at, to the right or to the left may not make sense. It may not be what you think it is. So we always say clockwise or counterclockwise because those things are true no matter where your current position is. You can think of each quadrant as 90 degrees in a rotation. That's because from here to here is a 90-degree angle. From the x-axis to the positive y-axis is 90 degrees. And from the positive y-axis to the negative x-axis, the negative side of the x-axis, that is another 90 degrees. From the negative x to go straight down, from here to here, from one quadrant to the other is 90 degrees. Let's see that with some pretty easy to distinguish shapes. The best way to look at rotations is you look at one single spot. And that was also true for dilations. For dilations, if you found how one dot and the coordinates of that one dot were going to change, then you could tell how the entire shape was going to change. For rotation, the top, the one that's above the letter A, starts off at the top, but then it points to the right in the final part. It starts off at the top and now it's on the right. So how did this is the preimage, and this is the image. The image is the new thing and the preimage is the original one. In which direction did it turn? Okay, well, the most obvious one is it went from pointing up to pointing to the right, like I said before. So the fastest way to do that would be to rotate in that direction. And if we draw a circle, that is the same direction that a clock hand would go. So clockwise clockwise, that turn would have been 1 quadrant over, and our notes say each quadrant is 90 degrees. So since it just moved 1 quadrant clockwise, it moved 90 degrees clockwise. But did you know that if you turn clockwise, did you know that it was possible that if you're at 12 o'clock and you followed the clock backwards, if you went long enough, you could end up at 12 o'clock again? So that means that there's 2 ways we could spin number 1. Number 1 could have turned this way to end up in the same spot. If we're spinning it, then after the first quadrant of turning, this dot would have been facing this way. It would have been at the left after 90 degrees. Then after turning another 90 degrees, it would have been at the bottom. Then after turning another final 90 degrees, it is now at the right. So depending on which way you visualize this shape rotating, it either spins 90 degrees or it spins 3 times 90 degrees, which is 270 degrees counterclockwise. It moved 3 quadrants, and each quadrant was 90 degrees, so we did 90 times 3 to get 270 degrees. All the other ones are going to be a lot faster now after we've seen that. So let's look at any specific corner. All right, let's do number 2. We need to pick something that's really easy to tell and distinguish. Since these 2 angles are the same angle, I don't think that would be the best point to pick, because if we rotate this one, we might think that it ends up over here at the closer to the origin. To make sure that that confusion doesn't happen, we should pick a point that's unique. And here is the only right angle on this shape. So let's make a dot at that point that's only happens right there. So to go from here to here is let's look. It's going down and around and up. Down and around and up is counterclockwise. So the first number of degrees we're going to count is counterclockwise. And how many quadrants did it move? 1 quadrant, which means it moved 90 degrees. Now let me erase that so we can do it the other direction. If we move this way around, the long way around, then we move 1, 2, 3 quadrants in the other direction. And that would be 270 degrees clockwise. Let's see about this one. Well, the only hint that we have that this is even a rotation is that the C is upside down over here. The C on number 3, they put the prime at the bottom, which means it's really upside down. So let's get this outer corner. And if we turn this way, then the corner, if we just twist this shape, then the corner would have ended up this direction. I'm not good at drawing parallelograms, but it would have ended right there. Then if we turn one more corner, we see that it's going to be on the outside edge. So how many degrees was this? We went 1 quadrant, 2 quadrants over. 2 quadrants. And is this the direction of a clock? We went left, up, and around. Left, up, and around is clockwise. That was 2 quadrants. So we're going to do 90 times 2 to get 180 degrees. Now let me erase those hints, and let's go the other direction. From the bottom left, we go 1 quadrant, and then it would have been facing the bottom right. Then if we turn 1 more quadrant, the whole shape is turning. Then we would have ended up right there at the top right again in quadrant number 1, but we moved a total of 1 quadrant, 2 quadrants, which will be another 180 degrees, counterclockwise. Now that I've done some weird shapes with you, this is asking you to do the same thing. So while you're taking your notes, just pause your video and try to do these 3 questions on your own. It's the same exact thing. You're just going to count. You're going to pick some unique spot and then rotate and see how many quadrants over that was, and then whatever number of quadrants, it'll be 90 degrees for each quadrant you moved. Okay, pause your video. I'll show you the answers in 5 seconds.